Welcome to this explainer. Okay, I want you to just think about this for a second. You lived an entire, completely vibrant life before the age of 3. I mean, you were born, you opened your eyes and saw the world for the very first time. You heard your mother's voice, you tasted actual food, you took those incredibly wobbly first steps, you even spoke your first words. It was a time of just massive, monumental milestones. And yet, you remember absolutely none of it. Not a single fleeting moment. It's just completely blank.
So, what happened? Where exactly did those memories go? What happened to the first 3 years of your life? Now, most people, and maybe you're one of them, assume the answer's pretty straightforward. You might think, well, obviously, I was just a baby. My brain wasn't ready yet. It was simply too immature to record anything. But here's the thing. Actually, scratch that. It's a total myth. Your baby brain wasn't failing to record your life. It was recording absolutely everything. So, what came along and destroyed it?
All right, let's get into Section 1, the infantile amnesia mystery. Okay, let's dive into this. To really solve this mystery, we actually have to go all the way back to 1905. That's when Sigmund Freud coined the official term for this bizarre phenomenon, infantile amnesia. And it's a completely fascinating concept because it highlights a really strange paradox. See, infant memories are successfully formed and recorded in the moment, but then they are systematically lost to us as adults.
And we know for an absolute fact that babies can form memories thanks to this brilliant experiment from the 1980s. Psychologist Carolyn Ravi Collier over at Rutgers University ran this beautifully simple test. She basically tied a little ribbon from a baby's ankle to a mobile hanging right above their crib. Now, the babies very quickly figured out that kicking their leg made the mobile dance around, and they absolutely loved it. The amazing part? When she brought those exact same babies back days later, they remembered. They started kicking immediately. I mean, even 2-month-olds retain that memory for a few days. And 6-month-olds? They remember the trick for weeks. Infant brains are incredibly capable of learning and storing information. But as you can see, by the time adulthood rolls around, every single trace is wiped clean. So why on earth don't they last?
That brings us to Section 2, building the memory engine.
To crack this case, we have to look at our first major suspect, which is the physical structure of your developing brain. The mechanics between you right now and you as a baby are very, very different. You have this small, curved structure deep inside your brain called the hippocampus, and it encodes lived experiences, like, say, a birthday party or a walk in the rain, into episodes that you can later replay. Now, in an adult brain, the hippocampus works seamlessly with the prefrontal cortex to successfully tag, store, and retrieve these files. But look at the infant brain side here. That system is severely underdeveloped. The connections are literally still under construction. There's a key region called the dentate gyrus that basically acts as a major gateway for new memories, and that gateway isn't fully wired until somewhere between the ages of 2 and 4. And this brilliantly illustrates why your infant brain could easily capture short-term memories, but it just completely lacked the hardwiring to move them into long-term storage.
Moving right along to Section 3, growth overwrites the past.
But you know what? A lack of wiring is really only half the story. Back in 2014, neuroscientists Sheena Jocelyn and Paul Franklin started focusing on a biological process called neurogenesis. During your first few years of life, your hippocampus is just pumping out brand new neurons at a truly extraordinary rate. And this is absolutely essential for survival. These new brain cells are wiring up the very circuits you are going to use for the rest of your life. But Jocelyn and Franklin proposed an almost absurd hypothesis. They thought, what if the exact process that builds your brain is the very same process destroying your memories? They suspected that every single time a new neuron forces its way into an existing circuit, it literally disrupts the connections that were already holding your memories.
So to test this wildly fascinating idea, they turned to mice. And honestly, the results they published in the journal Science were completely staggering. When they took adult mice and artificially increased their neurogenesis, basically tricking their adult brains into producing rapid new cells like a baby would, those adults suddenly started forgetting things they had previously learned perfectly. No way, right? And then, conversely, when they took infant mice and artificially slowed down their neurogenesis, those baby mice actually held onto their memories way longer than normal. This completely proved that rapid physical brain growth actively overwrites stored information.
Which leads us to this incredibly vivid realization. Your earliest experiences weren't lost because they were never saved. They were lost because your brain kept building new rooms and tearing down the old walls in the process. Your baby brain wasn't weak at all. It was just incredibly, overwhelmingly busy growing.
Let's look at Section 4, the birth of you.
So we have underdeveloped hardwiring, and we have rampant physical growth overriding circuits. But there's actually a third,
deeply psychological suspect that developmental psychologists Mark Howe and Mary Courage brought to light, autobiographical memory. Now, this isn't just remembering how to kick a mobile. This is the specific kind of memory where you are the main character of a story. So the crucial point is, to replay an experience in your mind, you need something we all take completely for granted today. You need a sense of self. You need an internal narrator to anchor that memory to. You have to understand that you exist as an individual, separate from the world, and that things are happening specifically to you. And before 18 to 24 months of age, infants simply do not have this. There is literally no you yet.
And we can actually see the exact developmental moment this internal narrator is born, using the classic mirror rouge test. It's so cool. If you secretly put a little dot of rouge on a baby's nose and put them in front of a mirror before they're 18 months old, they'll treat their reflection like it's just another random child. You know, they might wave at it, but they do not reach for the mark on their own face. But after 18 months, everything changes. They look in the mirror and immediately reach for their own nose. They recognize that the person looking back is them. This pinpointed moment of self-recognition tracks perfectly with the earliest age that autobiographical memories can begin to form. You can't remember being a baby because, well, there was no you to claim those memories.
Finally, Section 5, How Language Shapes Memory.
And that brings us to our final suspect. Developmental psychologist Catherine Nelson spent years studying this, and she found that language fundamentally structures what we remember. Think about it. Before you had words, your experiences were just these raw sensory impressions, a sound, a soft texture, a bright light, a sudden rush of emotion. But without language to organize those impressions, they had absolutely no framework to attach to. Once children start speaking, and specifically once they start having conversations with adults about the past, like, hey, remember when we went to the park today? Their ability to form lasting memories just skyrockets. Language gives memory a skeleton. Experiences without language are literally like water with no container. They exist beautifully in the moment, but then they just slip right through your fingers.
Now, what's really interesting about this data is how it's powerfully proven by cross-cultural research. Psychologist Chi Wong at Cornell University discovered that the average age of a person's earliest memory actually shifts depending on the culture they grew up in. In Western cultures, where parents are constantly narrating their children's lives and asking questions to build personal stories, earliest memories start around 3.5 years old. But look at the Maori culture in New Zealand. They place a massive cultural emphasis on oral tradition, personal history, and storytelling. And because of that rich linguistic environment, their average first memories reach all the way back to age 2.5. Conversely, in some East Asian cultures where early childhood narratives are a bit less focused on the individual self, first memories tend to start closer to age 4. Your culture's language literally shapes how far back your memory reaches.
So, let's pull all of these clues together. What actually happened to your first 3 years? Well, it wasn't just one thing. It was this spectacular, layered combination of events happening all at once. Your hippocampus wasn't fully wired for long-term storage yet. And even as it started to try, a rampant flood of new neurons was physically tearing through and overriding those very circuits. Psychologically, you lacked the continuous sense of self required to anchor an experience. And you just didn't have the language yet to give those raw sensory experiences a structural container that could actually survive the test of time.
Every single human being goes through this exact same process. We all have this black hole where our first few years should be, which leaves us with a truly eerie, almost uncomfortable philosophical question. If you had no continuous sense of self, and the physical brain that held all of your earliest experiences completely rewired itself, neuron by neuron, beyond recognition, is the baby in your old family photos actually you? Or is it someone else entirely? Someone who just happened to live in the exact same body, but whose mind was completely disassembled and rebuilt?
Your infancy wasn't lost because your brain was too simple or too dumb. It was lost because your brain was busy doing something infinitely more important than just recording the past. To build the incredible, complex person sitting here learning today, your brain quite literally had to destroy the baby that came before. And that is a truly fascinating trade-off.